Hey robot makers, how you doing? Hope you're having a good day so far. So do you want to know how to install ROS on a Raspberry Pi 3, 4 or 400? Mostly just the 4 or the 400, then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots and bring them to life with code and have a whole load of fun along the way. Okay, and we've also got another person on the show today in the background. That way. This is Alex, our new moderator. So if you're watching in the live chat, say hello to Alex as well, and she can introduce herself. So let's get on to the show, shall we? Okay, so this is all about how we install ROS, the robot operating system that we looked at last week, on a Raspberry Pi 4 or 400. So technically you can install this on a Raspberry Pi 3, but we're not going to be looking at that. It's a little bit low in resources to do that. It's not quite quick enough. So this is just mainly focusing on the 4 and the 400. So the difference between the 4 and the 400, if you're not familiar with those, we'll go over the differences in a second, but essentially the 4 is just this small form factor and the 400 is the keyboard variety. Looks a little bit like this. Okay, so the session goals for today, we're going to learn how to install ROS 2 on a Raspberry Pi 4 400. We're going to look how we download Ubuntu for the Raspberry Pi, because we have to use Ubuntu for this. We're going to be looking at writing an SD card for using the Raspberry Pi Imager. We're going to be looking at how we get Ubuntu on Raspberry Pi and doing a bit of configuration. There's not very much, to be fair, to do. We're going to look at how we install ROS. It's not as complicated as you might think, a bit fiddly perhaps on the command line, but we've got some commands that are quite simple to use. And we're going to have a quick look ahead at something really, really cool, which is Lidar scanning with an RP Lidar sensor. I've got one of these that I bought this week, and using ROS we can do some 3D mapping and scanning, so we can use that with ROS. Can't wait to show you that in the demo. Okay, does that sound cool? Cool. Right, so ROS it runs on Ubuntu. So it's a 64-bit operating system. There is a 32-bit version of this, but to access large amounts of memory, which ROS requires, you need to have something that's 64-bit. If you've not come across the difference between the two before, it's just memory addressing. So 32-bit processors can only access 4 gig of memory maximum. 64-bit can do an order of magnitude more than that. And there is a variety of Raspberry Pis out there. So the Raspberry Pi 3 is technically a 64-bit chip. However, I think the memory capacities of the Raspberry Pi 3 only go up to 1 gig. The Raspberry Pi 4 came out and had 1 gig originally. Then they released a 2 gig and a 4 gig and an 8 gig version. And then there was also the compute module, which has now been upgraded to a version 4 of the chip as well. The 400 is exactly the same as the Raspberry Pi 4, but comes in a keyboard form factor. So I've lifted this up before. This is actually just a Raspberry Pi keyboard, but the one I've got on my desk just over here is actually the real McAleer. This is a Raspberry Pi 400, so it looks exactly the same as the keyboard. It's exactly the same size. The only difference is it actually has a Raspberry Pi 4 inside. Now, some people might say, you're wrong there, Kevin. There is actually a difference between the 4 and the 400. They did a small release to the 4 recently to bring it up to the same chip speed. I think the chip speed on the Raspberry Pi 400 was fractionally faster than the Raspberry Pi 4, but we'll not get into that. So why do we need to install it on a Raspberry Pi 4 400 or the compute module 4? And why do we need to use Ubuntu for this as well? So Raspberry Pi, the Raspberry Pi operating system that runs on all Raspberry Pis, is actually a flavour of Linux, but it's been highly optimised for just general tasks, aimed at education and software development and so on. Whereas Ubuntu is more of an enterprise version of Linux. So when they've developed robot operating system, they probably developed this not on a Raspberry Pi, but on regular hardware. And then they've ported the stuff across to the ARM processor. So the fact that we can run Ubuntu on a Raspberry Pi means that we can actually use ROS on a Raspberry Pi as well. So that's why we have to use Ubuntu and we can't just use the standard Raspberry Pi OS. So I think I've covered that in one of the points there. So therefore we need to install Ubuntu Linux on our Raspberry Pi. And Ubuntu does come in that 32-bit or 64-bit version. And for ROS, we need to make sure we're using that 64-bit version. And the Raspberry Pi with 4 gig or better. If you try and run it on 2, I did this earlier. I think it was this black Raspberry Pi 4 that I've got here. I think this only has 2 gig of RAM. And after a while, it would, in fact, it says on the back of my little sticker, 2 gig of RAM. This one sort of paused every now and again and then stopped working, so you need a bit more RAM. So ROS isn't a cheap date, I've said there. Cool. What else have we got on here? So yes, downloading and imaging. So we need to go to ubuntu.com and we need to grab the latest image. Well, is it the latest image? We need to grab an image of the Ubuntu for the Raspberry Pi. So let's just break out onto, I'll just open up a browser for a second and we'll just grab the version that we need for this. Let me show you how this works. So if I go back over to here, right, so we're on the ubuntu.com site. If I go over to the downloads tab, and the latest version is actually 21.10. We don't want that latest version. ROS hasn't been compiled for that version yet. It has been compiled for the 20.04, and that LTS is like long-term support or something. So that's the version that we actually want to have. However, we don't want to download that straight off. We want to go over here to the Raspberry Pi 2, 3 and 4 link. And that takes us to this this button here. And we can see here we've got two flavors of it. We have the server and we have the desktop. The desktop is only coming in the 21.10 version. We don't want that one. We want to make sure we have the 64-bit version of the 20.4.3. That one definitely works with ROS. And you can see there it says it works on the Raspberry Pi 2, but only the 32-bit version. We can't use that one. So it's either a Raspberry Pi 3 or 4, or the 400, or the Compute Module 4. However, because of that memory requirement of ROS, that actually means that it has to be a 400 or CM4 Compute Module 4 with at least 4 gig of RAM. So we'd simply click on this download button here. I'm not going to click on this. I've already downloaded this in the background, but that's what essentially we need to do there. So we're going to click on that. We're going to download that image to our disk. Depending on how fast your broadband is, that might take a little bit of time to do or not. And then there is a tool that's the Raspberry Pi imaging tool. So you can go over to Raspberry Pi. Let's go over to, let me just open up a browser window and we'll go to raspberrypi.org. And let's just load that up there. And on here, if we go over to software, we can find the imaging software, which is just here. So if you go to that download for Windows or Ubuntu or whatever you're using, you can then have that software on your computer. So that's what we're going to be using to write the image. Now I've got that loaded here. If I actually load this up, I'll show you what this looks like. So it looks a bit big here because I've got this zoomed in. So you can click on like choose operating system. Now normally you'd go for like Raspberry Pi OS. Now they do have Ubuntu down here, however, it's 21.10 and that's not compatible. They do have the server version, so you could click on that one, but that's the 32-bit version and not the 64. So that one would be okay, the 20.4.3. We could use that one to burn the image. Now this is, remember, this is the server version and not the desktop version. And the difference between the two is the desktop version, you get that nice graphical user interface, whereas on the server version, it's like a command line. It's just designed to be enterprise software. So we're going to use the server version. Don't be scared that it's command line only. We can figure this out. So we've started downloading that Ubuntu 64-bit server 20.4.3 in the background. So we can click on choose OS from our Raspberry Pi imager, but instead of using that image up there, we're actually going to click on use custom. So use custom means that we can select the image that we've just downloaded. So by clicking on that, we can then just grab the image that we want. So if I just grab, let's see if I've got one to hand here. So I've got a little memory card just here. I'm going to put this into a slightly larger memory card reader, just because the memory card reader that I've got on my machine here, if I just plug this in down here, it takes that size of card. Right, so I've just plugged that in there. Now if I go over to my Raspberry Pi imager now, I go to choose OS, let's go to custom, let's go to the version that we want, which is the server 64-bit 20.4.3, and then it says choose the SD card. So I'm looking on here for that 32 gig card. So there we go. If I click on that and then I can click write, it then says, are you sure you want to do this? It's going to erase it. Yeah, why not? It's now just popped up a message just for me to type in my username and password to provide access to that, and once I've done that, it will then start writing that card. So we're not going to sit here for like 10 minutes or however long that takes. We'll come back to that in a bit. But that's essentially what we do to write the card. once we've got our freshly burnt card, we're going to put that into either the Raspberry Pi itself. So let's just grab one here. So this one goes this way round. Let's see if we can get that into focus there to move my face out of the way. So that just goes into there. It doesn't sort of click in on these new ones, it just kind of pushes in and it's kind of facing down. And similarly on the back of the Raspberry Pi 400, there's a little slot there that you can just push it into. And that's it. So I don't think you need a very large card. So I've gone for 32 gig cards. I think I've got a 64 gig version as well. So they're not massive capacities. Quite easy to use them. And then, yeah, installation takes quite a while. So I've got a nice little monitor that I use when I'm installing things. It's just a HDMI monitor. And it means I can connect it up to a Raspberry Pi and I can just check on progress. I've also got like a standard Raspberry Pi keyboard as well that I can just plug in wherever I've put the cable for that. It comes like with a little cable. You can just plug this into the Raspberry Pi and you've got a keyboard and mouse then. So that's all good. So I can just show you that there. This little monitor I've got here just has HDMI cable in there. The HDMI cables for Raspberry Pis are quite small. I found buying a cable for that was better than buying like a little converter thing because I just had them break and snap on me. So the it's a micro USB connector on the, not micro USB, micro HDMI connector on there. They're really, really small. Cool. Okay, let's get back to the notes. So yes, what we do is we just leave it installing when we first boot up the Raspberry Pi, and it just needs to do a couple of checks, I think, and then it presents you with a login. So yeah, this is in there. In the screenshot, I use the desktop version of Ubuntu, which has a nice user interface. You won't see that if you've just used the server version. It's just like lots of text. So logging into Ubuntu for the very first time, the default username is Ubuntu. The default password is also Ubuntu. So best practice to change that to something that you'll not forget. And then I think it doesn't let you go any further, so it'll say you type in Ubuntu as the login, you type in Ubuntu as the password, then it says type in the password again, and then it lets you change it, and I think it just checks. So that's nice and simple. So if you like these shows, please make sure you like, comment and subscribe to this channel. If you're watching on the live show on Facebook, on Twitch or Twitter or on YouTube, drop me a comment what you think about this particular topic about ROS. Let me know if you want to know more about this. Make sure you've clicked the bell icon as well so you get notified whenever a new video is released. And if you like the show, give me a thumbs up as well. If you don't like it, give me a thumbs down or don't, or write in the comments as well. Awesome. And Alex has just posted a link there as well to the Buy Me a Coffee. So if you want to help out the show, you can also buy me a coffee. So if you go to buymeacoffee.com/Kevin McAleer, and that'll help pay for the website hosting, the royalty-free music that I use, the graphics software, the streaming software. It's not quite Halloween yet. And also all the equipment as well. So I've got all these different cameras and fancy stuff to show you too. So if you want to help with that, you can go to buymeacoffee.com. And as Alex has just shared a link for as well there is the website smarsfan.com. So I'm always updating SmarsFan with new content and new tutorials. So I think 2 weeks ago I launched an Arduino course on there for free. So if you go to smarsfan.com/learn, you'll find the Arduino course on there. And I'll be writing up my notes as well about ROS because there's quite a lot to remember about ROS. So I'll write some notes up and put it on there too. Now, the other thing I just want to make sure people are aware of, turn that down a bit. So this is the 10k challenge. I'm trying to reach 10,000 subscribers on YouTube. So if you can help me reach that goal, if you're watching this and you haven't already subscribed, please hit that bell button now, and also the subscribe button, and that'll help me grow the show a bit further. Okay. So yes, Alex is related to me. Alex is my daughter. So Alex, just give everybody a wave in the background. There's Alex. She's my new moderator. Yes. Cool. So that's a like, comment and subscribe. Let's get to the next bit. And I mentioned about the 10,000k subscribers there. We're on our way. We're nearly at 3,000 now. So this is what day are we on today? 24th, is it, of October? And we've got nearly 3,000 subscribers. So we're on our way there, but I want to get there a bit quicker. And I do a show every single Sunday at 7 o'clock GMT-ish as well. So make sure you join in if you're not already joining in live. So we've got quite a few people watching the show at the moment. It says we've got 15 people watching currently, so hello to everybody that's watching currently live. And I'll come to the chats in a minute. So if you've got any questions for me, drop them in the chat section as well. And also, if you want to support the show, you can do a live chat. You can a super chat. You can click the little dollar button next to the I think it's like an emoji thing just above the chat box, and you can drop what's it called, a super chat. And if you do that, I think we get a little pop-up on the screen as well happening. It's quite fun, but it also helps support the show. Okay, back to the content then. So secure shell. So what we're going to do once we've installed that, so I'm just going to check and see, has it actually finished writing that image out to the SD card? And it has. If I go back there, it says you can now remove your SD card from the reader. So I'm just going to do that. So I've got my little SD card here. In this case, I'm going to, which one shall I use? This one says it's a 4 gig, so I'm going to load this one into the 4 gig. Put a little sticker on the bottom so I could remember this is a 4 gig Raspberry Pi 4. And if I plug this in, I'm just trying to think the best way to show you this. Let's do it like this. So I have a little capture card that I can plug into my live streaming software, and hopefully that can show you what this desktop looks like when we boot up. So let's do that if we can. Now, of course, I've not got my card thing ready, so that's a bit of a foobar. I knew I should have got that ready before I did the show. I'll come back to that. So what we'll do, we'll just carry on with the presentation, and then we'll come back to that in a second. But we can actually start using that image right away. Okay, so what we're going to do once we've put our SD card in, we've booted up the machine, we've changed our password. At that point, we can actually use this secure shell to connect to it from another computer. And the reason we'd want to do that from another computer is we might have a faster computer, or one that's the Raspberry Pi might be on a shelf or in a loft or in a drawer or something that's powered up, and you know, you don't necessarily want to do that, connect to it with a keyboard and mouse and all that kind of stuff. It might be built into a robot as well, so it's best practice to be able to connect to it remotely using this secure shell. And all we need to do is just type SSH, the name Ubuntu, which is our username, and then the IP address of that computer. So what I do with my machines, if I just go back to that overhead, this cable here is an Ethernet cable, and this means it's connected to my network. Let me just go back to myself for a second. So that means that it's connected to my network, and it gets an IP address automatically. So I don't need to configure any Wi-Fi or anything like that. So we can configure these for Wi-Fi as well, but it's just an extra step. We just need to change a configuration file. So for this one, we're just going to put it on the LAN. We're going to have a fixed an IP address, whichever the router gives it, and that's what we're going to use to connect to it. So it looks something like 192.168.1.115, for example. You then enter your password, and it's just like logging in to the machine if it was right in front of you, and then that will log you into your Pi. So we'll do that in a minute. And you can do this, like I said, right away if you're connected to the Ethernet. If you're using Wi-Fi, there's like an extra step just to configure the Wi-Fi. You probably will need to plug that into a HDMI monitor, have a keyboard plugged in so that you can edit the file. I think it's something like WPA. It's like a web thingy-mabob. So once we've logged in, we then need to do a couple of things. So there's some commands here, and I'll put these into a text file and put it on GitHub so that we can remember what they are. So what's going on here is there's a package manager on Ubuntu that's called apt. Aptitude is the full name for it. And Aptitude can connect to third-party repositories, and the repository is just like a package library. So there is a package library on ros.org that we want to connect to grab all their libraries for ROS, so that we can then install them using the apt command. So sudo is our super user do. So sudo apt key add adv, which is like advanced, and then -- fetch -keys, and then the URL for the ROS repository on GitHub. So that https://raw.github-usercontent.com/ros/rosdistro/master, and then ros.asc, which is like ASCII, I think. And that just contains like a hash key, which can then be used to validate that your connecting to the repository legitimately. So once we've done that, we can then do sudo apt add repository and then HTTP, and it's not package, sorry, it's not HTTPS, it's HTTP, so it's like the non-secure version, packages.ros.org/ros2/Ubuntu, and that will basically add that repository to our list of possible repositories. Once we've done that, I think there's probably a step missing out there, which is just to do sudo apt update, and that will grab all the latest repository metadata. So it's like a list of all the things that you can install onto your machine. Then you can do sudo apt install ROS-Foxy-ROS-base, or if you want the desktop version with all the fancy tools, which I probably recommend, go for sudo apt install ROS-Foxy-desktop. So this Foxy thing, that's a key name for the version of ROS that we're using. So the version of Ubuntu we're using is called Focal, and the corresponding matched version of ROS is called Foxy. So Focal Foxy is the kind of pair there. So each time they do a new release, they just increment a bit like Android. They'll increment the letter that they're using. So I think there's like a galactic version as well for the newer version, the 21.10 I think it is. But we're not using that. That's not fully supported yet. It's still kind of in beta version. So let's have a look what else we need to do. So once we've typed in those commands, that will then mean sometimes it says you get an error message waiting for cache lock. And what I then type in is I will just shut the machine down, and it might just say it's waiting for an active install or a background install to complete. So we just let it do that, and then it reboots, and then we're good to go. We can just type in that command again. And it takes it about 5 to 10 minutes, again, depending on your broadband, to install a whole load of packages and things. But once we've done that, we've nearly got ROS installed then. So let's have a look what else we need to do. So once we've that command's finished, and it's got all the packages there, we then need to do this thing called source. So source is a way of setting up all the environment variables for a particular console that you're using. So there is a file that's been created in this optional folder, so /opt/ros/foxy/setup.bash. If we type in source and then that path, it will load all the environment variables for the ROS environment. And if we want to, we need to do that every single time we open up a new terminal, so that's a bit of a pain. So what we can do is we can just echo that. Echo just means print out. We can echo that whole thing into, so that's what the double arrow thing means, put that into, and then the file, so we've got that little tilde /dot bash rc. RC is run commands. Bash is the name of the terminal shell that we're using, born again shell. So by adding that line into there means every time we open up a new terminal, it will run that source file for us, and therefore we've got the full access to all the ROS commands that we need to access. So that's the only commands that we need to run, I think. So the other thing I want you to do, if you are so willing, is to join the list. So I have a mailing list I've created a while ago and I've started to use now, and our social media coordinator will help keep this active as well. And this will tell you of all the shows that we've done each week, give you a top tip, and also links to all the content that we're doing as well. So sometimes we get a lot of questions about, have you got a link to this, or where's the repository for that? And although I do put a lot of things in the description, sometimes it's a bit easier to explain that in an email, and then you've got a copy of that all in one place. So if you want to join in that list, go to action.smartphone.com/join-the-list. That's in the description, and I think Alex has put a link to that as well. And yes, you can then join the list and get a weekly email and more. Cool. Okay, let's carry on and see what we've... So here's some tips already. So these are some of the mistakes I made whilst figuring all this out. So install the binaries. Do not try and build from the source. So if you try and build from the source, you really need to be, an expert coder, because there'll be all kinds of dependencies and things that you need to fix. If you haven't got that skill set, just stay away from that. And as I mentioned before, the ROS releases are tied to a specific Ubuntu version. So save yourselves lots of time. Don't try and use an unmatched version of Ubuntu with a different version of ROS, because it'll just be a headache. So use the Focal Foza 20.4 version, either the desktop or the server, and use that with the Foxy version of ROS, and you can do everything we've done here today. Another thing that also helps, I've found, is if you do that sudo install build essential, that will also help with some package stuff later on. So there are some things that need to build, so you need to just install that as well. That just helps. Okay, so I want to talk about Lidar scanning as well today. So we're going to have a look at the install of Ubuntu, but I also want to show you this thing because I bought this week and it is amazing. So this is an RP Lidar. It's £99 to buy, and it can take 8,000 measurements per second. And what it is, I'll show you this thing. It spins round, and at the very front there, it's got a Lidar and a sensor. So it fires out a laser and then it comes back, and it can use like the speed of light, calculate how long it took to get where it's going and how long it took to come back, divide that by 2 so you only get the one distance, and then you know how far away an object is. And it's spinning round. It's not like massively spinning round, it's just spinning round. And mechanically it's quite simple. It has a little DC motor just here. See if we can get this a better shot. I've got a DC motor here, literally has a belt that spins it round. And then if you think, well, if it spins round, how does it send signals from this device to this little board underneath? And I was watching a video by Andreas, the one of the good YouTubers that you probably follow already, and he was saying that there's like an LED and an LED receiver underneath here, and then this just sits on top, spinning round on a what do you call it? One of those things that helps ball bearing things. It spins around on that, and it just uses the LED and the LED receiver to transmit data between the two devices so that they don't need to physically connect. And then to power it, it uses wireless, like a wireless charger. It has like an induction loop and an induction loop on here. So this can be powered, not physically connected, but send and receive data through this cable. And then it's serial data. So there's a little serial to USB. If I just move out of the way there. Oh, I just do that. You can see this just like a little USB connector thing. You can actually connect up a regular cable to serial if you want to do it that way. So I'm just going to put that back on my 3D printer there, and we'll have a play with this in a second. So yeah, it takes 8,000 measurements per second. It can do 12 meters as a range, so it's like really good range, and it's very easy to install because it's just plugging a USB cable into your computer. So you can plug this into your Raspberry Pi. I've got this currently plugged into the Raspberry Pi 400 that we're setting up, and you just need to follow a couple of instructions. I've been following Young Day's ROS 2 build, which is on GitHub, and it just works. So we can have a play with this in a second. And there's like another shot of it as well. Okay, so there is some software in ROS which is called visualization. It's RViz. And this enables data from any of our robot packages to be visualized in 2D or 3D. So this is where it gets really cool. So that laser scan data that's coming out of this, just as loads of serial data, can be put into this RViz, and then it can put it into a 3D model that we can see. And as a next step, and this is what I'm learning at the moment, we can build a 3D map of the room that we're in that our robot can use to do planning and mapping, so it can figure out where it is in the room. And it doesn't need to have an IMU. It can figure it out because it's taking that many readings per second. It can tell if it's changed direction or orientation. So this is like ridiculously smart. So I'll do that in a second and you'll see what that looks like. And the way that it uses this mapping thing, it's called simultaneous localization and mapping, or SLAM. So with our LiDAR sensor, you can build up a map for our robot. We can use the map to visualize in ROS RViz, and then we can simply create a map by moving the sensor around the environment. Like I said, it doesn't need an IMU to understand where it is, so we don't need one of those chips that I always struggle to get working, but where you can work out, which orientation you are, where you can have a magnetometer and so on. And this is perfect for creating mapping data. It enables our robot to move around our environment, map where it is, and then also understand where something was, and therefore it can avoid it if it's turning around and coming back. So it can keep an active map for planning in its head. And the module in ROS is called Hector SLAM, and we'll be looking at that in a future video, not too long off, hopefully. So shall we have a look at this? Shall we have a bit of a demo? So let me go over to my Raspberry Pi 400. So what I'm going to do is I'm going to bring up some consoles. If I go over here, so I've got some consoles I've connected to my Raspberry Pi 400. I ran those commands that we looked at earlier to install ROS, and I've now got ROS installed on this computer. So if I type in ROS2 even, I can see that I've got all the ROS commands ready for me. I've also downloaded the Young Days version of the RP Lidar software, and that means that we can have a play with this, and we build it using Colcon instead of what's the thing called? There's like two different build environments, and this one uses Colcon instead. It's like Cat Kiss or something, Catnip, I can't remember what it's called. Okay, so all we need to do on here then is, if I just start up, let me just find it, the RPI Lidar, and if I do that and then I go over to this camera here, let's try that one. This one here, we can see that that thing is spinning round. You probably can't see how fast that's spinning. It's not very, very fast, but it's kind of fast enough. And that's then sending out, and you've just got to imagine it's kind of like a flat plateau of laser. So it's not three-dimensional in every dimension of the room. It's just kind of a single slice. So you just got to bear that in mind while you're using this. So let's go over to this view for a second, and we can get some of these console things here. So I'm actually going to run 3 different terminals. So the first one there, this is the one that we've just started here, the RPI Lidar, and you can see there the firmware version, and it says it's mapping 7.9 thousand points a second. It's got a 12-meter range, and it's got an angle compensate of 2, whatever that means. Right, so I'm just going to clear this console for a second, and then we're going to run. TF is a translation software, so it translates from the world frame to the laser frame. Don't need to worry about that. It just is a piece of code that we need to run in the background to make this thing work. And then we don't need to run this one, but I want to run it just to show you. This is the client, and this is just grabbing all the data. So as I move my hand in front of it, you might see some of those numbers change, for example, but it's just basically scanning the room as we sit here. So that's actually running on our Ubuntu Raspberry Pi 400. That's just my desk here. So it's grabbing that data. We've got the LiDAR plugged in, this stripy cable here. So if I go to that view there, you can see the stripy cables coming round. If I go to that view, you might be able to see the whole thing's just sort of wired up there. Okay, and what we're going to do next then, if I go back to this view here. So I've got another machine, which is a completely different machine. This is my Ubuntu virtual machine. And let's just start this up. So Amuvial is asking, what do the numbers represent? Distances? They represent readings. So it is a measurement of distance, but I think it also has like a timestamp on there as well, and what angle it was at. So it's figuring all this information out. So I'm just going to type in my password in there, and once that accepts me in, right. So I've got another console on here. So this has got ROS installed as well, and what I've done is I pointed this ROS at the Raspberry Pi 400, and the way that you do that is just by doing some environment variables. I don't know if we can see this by the history command. So where I typed in ROS master URI, and I pointed that at port 11311 on 1115, which is the Raspberry Pi 400, and then I've also done ROS_IP, and that's the IP address of this machine. So those two can then speak to each other, and it understands where to find all the configuration and so on. Let's just clear that. Now what I'm going to run now is the RViz command. So if I run RViz, this will load up this visualization software. So what I'll do for a second, I'll make this full screen so that we can see what's going on. Yes, I've just answered that one. Yeah, I was asking about the numbers, and they are distances, but it's also, I think, a bit of extra data as well. Right, so I've got this environment here. This is the ROS visualization software, and we've got this kind of space here that we can see, and we've got some settings over here. So the first thing I'm going to do is I'm going to add in a laser scanner. So let's add that component in there. And then what we need to do is just tell it what topic we are going to use. So the software that we're using at the moment, that RP Lidar ROS package, is outputting on a topic called scan. So if we put that into there, we then change our fixed frame from map to laser frame. And let's see what else we need to do. So there we go. We can see that there's some red things just appeared on there. So what we're going to do is just increase the point size of that to maybe 3 so we can see that. Now at the moment that doesn't look very interesting or very understandable. So I understand, because I've played with this already, that corner there is actually the corner of the room that's just there. And because it's taken a slice, it's probably getting a bit of this monitor, it's getting me and my chair, it's getting that wall and all the other bits and pieces that we can just see off screen here. Might be easy to see on that view there. So yeah, there's all these other bits like the monitor and so on, me, my chair. So if we go back to that overview there, you can see there's quite a right angle. That is the corner of the room. And if I start to swing in my chair, you can see just here, that's me moving about. And that sort of circle that's just there is my microphone that's just in display. So, and in the other corner of the room, just out of the sight there, there's some sort of soft furnishing, so that's being absorbed. The laser is not bouncing back because it needs quite a hard surface to bounce back from. And we've not done any kind of clever mapping with this yet. This is just the raw data, but we can see there that this thing is actually working and taking, that's my hand that's just moving just there. It's taking the readings and it's putting it into this software. So how easy was that to do? We just needed to pull the package from the internet, from Youngdae's GitHub repository, and then I just had to do the colcon build, which is the build command. I'll cover all this in a separate video, so don't worry, but I just wanted to demonstrate this to you today about why we want to use ROS and why this is so cool. So that means we can put this into our robot, and it probably would fit on, maybe it's a little bit, I don't know, big for the top there, but we could put it on a Smars robot. This is going to be my Pac-Man robot. And that means that we can then scan the environment and use that information to report back where we are. So what do you think about that? We've got some other options on here as well. We can change the sort of colour of all the data that's coming through there. What else can we do? We can change the decay. This makes it look a bit messy, I think, but you can, if we change this to say 1 second, it will keep 1 second's worth of data. So as I move about, you can see it kind of stays there a bit more. If I sort of zoom in on that. And if I sort of move around, can you see it kind of stays there and then kind of dies off? I don't know whether that's useful or not. If I put that back to 0, it's now sort of real time. If I change that to 5 seconds, you'll see why it becomes a bit of a mess, because you just end up like, I'm just moving my hand in front of it there, and it's going to stay there for 5 seconds until it just destroys it. So let's put that back down to 0. And you can also choose, like, you know, what do you want the style of things to be? Do you want them to be points? Do you want them to be squares? Do you want them to be, let's put that back to 1 for, that's squares. Let's do it at 0.2 maybe. There we go. So that's the data coming through. So points looks like dots. Squares looks like squares. We're going to have flat squares. We can have spheres, boxes, or tiles. So for me, I think points looks great. So this is building up a point cloud. Cool.